Hi there, I want to show you an example of a typical kind of rational equation problem. It's called a combined work problem. So here's the kind of setup you'll usually see. So I can rake my yard in 75 minutes, and I have a helper, Jake, that can rake my yard in 60 minutes, each of us on our own. And so then the question will ask, how long would it take us to rake the yard together? So this seems like a tough problem. The actual setup ends up being pretty simple here. So the key thing is understand what you're trying to find. So we're trying to find the time for Jake and I to rake the yard together. So we'll just set that equal to x, like that. And then there's a key concept. Is that rates add together. Okay, so if you remember the example I did in class when I talked about running with the wind at my back, my combined speed would be the speed that I run at plus the wind speed. So that's a key concept. Times don't add together. That wouldn't make sense that raking together it would take us 135 minutes. So times don't add together, but rates do. So that ends up being a key thing here. So the thing about a rate, the rate's just about anything per some kind of time. So my rate's going to be that I can rake 1 yard per every 75 minutes. So this is just like running at a certain miles per hour, except I just have a different kind of rate right now. I can do 1 yard in 75 minutes. So if that sinks in, then it'll make sense that Jake's rate is 1 yard per 60 minutes. And the key thing is that rates add. And so our combined rate, first of all, in terms of what we're trying to find, is 1 yard per x minutes. That's what we're trying to find, is how long it'll take us to rake it together. So me and Jake together can do 1 yard in x minutes, but we also have these expressions for our individual rates. And so if you're going to combine two things, you would add them. So there's an equation that gives our combined rate. This is our combined rate as a sum, and then here's our combined rate as an algebraic expression. Key thing now to notice is that's a rational equation. So now all we got to do is solve it. All right, so oops, lost my piece of paper. Okay, so we start getting ready to try to solve this equation. Sorry to be so messy there. So we start getting this together to start trying to solve our equation. So we factor all the denominators like that, and then we go and try to get our LCD. So this one's looks a little tricky, but we just follow our rule. We find anything that's listed, there's a 2, to the highest power it's listed to. Okay, then there's a 3 in several places, but it only appears to the first power. Then there's a 5 that appears. Highest power it appears to is to the second power. And then over here we have this x. So there's our LCD. You could multiply that out, but then figuring out what you need to multiply these things by will get confusing. So I'm going to leave it in factored form. So now we need to convert everything to have the LCD. So I have 3 times 5 squared here. So 3 times 5 squared, I need a 2 squared and an x. And then here I have 2 squared times 3 times 5, so I'm missing a 5 and an x. And then here I only have x, so I need to put all those numbers in. Like that, and then I go and I can combine all of it. I can just do all these multiplies here. Remember, don't reduce or we'll lose our common denominator. So we have all of this stuff. Notice that all my denominators are the same, so remember, as long as all the denominators are the same and you have an equation, you can cross them out. I'm going to go ahead and multiply these numbers now. I don't need them in factored form anymore. So I end up with 4x plus 5x is equal to 300. Think how complicated that problem looked at first, and look how easy the equation ends up being to solve it. Get 9x equals 300. We divide by 9. And end up with x is 300 over 9. Remember, if you're solving a rational equation, you usually want to keep it in fractional form, so that'd be 33 and a third. Now we got to think about what that was. This was our combined rate, so those are going to be minutes. So we have 33 and a third minutes. And then remember, always answer a word problem in the context. And so it would take both Jake and I to rake that yard in 33 and a third minutes. Now, there's also a general concept you can kind of shorten the process here, these actually end up being pretty straightforward. So I'm going to say thing one. This is me and this is Jake in that previous example, but you'll see a problem that has pipes or something too. So I just call it thing one. So you're going to have two, or you could even have more tasks, but thing one takes T1 minutes. So this was my 75 in that example. Thing 2 takes T2 minutes, so that was Jake's 60 minutes, like that. And then you always just let X be the time it takes to complete it together. And what ends up happening, you just do 1 over the first time plus 1 over the second time equals 1 over X. And just make sure you realize these are numbers. This was 75 and 60 in that last example. And you can solve all those equations that way. One thing to point out too, you could have 3 tasks, and so you would just have another sum right here plus 1 over T3 to fill in. Alrighty, I hope that helps.